We're carrying on with permutations and combinations, and in this video we're going to go through some exam questions. I'm not going to read out the question fully, so if you want, pause the video here to read it yourself. I'm just going to highlight the information that I need now. So I need to know that there are 7 men and 6 women in the jogging club, and I need to know that they want to make a team of 8 runners. And we have to work out the probability that the team of 8 will have more women than men. So here we have 7 men and 6 women, giving a total of 13 people to choose from, but we only want to choose 8 for the team. We're going to write down, first of all, the equation for combinations, and then you have to write down the configuration of what teams are going to satisfy the requirements of more women than men. In this case, if you have 4 women and 4 men, that does not satisfy the requirements because it's equal. But if we have 5 women and 3 men, or 6 women and 2 men, these teams satisfy the requirements. And we can't have more than 6 because there aren't more than 6 women. So to work out how many teams have 5 women and 3 men, we need to have 6 choose 5 times by 7 choose 3. And for 6 women and 2 men, we have 6 choose 6 times by 7 choose 2. The calculation is relatively straightforward, so we end up with 6 times 35, which is 210. And don't forget that 0 factorial is equal to 1, so the second configuration we end up with 1 times 21. And adding these together, we get 231 different teams that are made up of more women than men. To find the probability, we need to divide that by the total number of teams possible. And the calculation for that is 13 choose 8, which gives 1,287. So the probability of having a team of more women than men is 231 divided by 1,287, which is approximately 0.1795. So pause the video here again if you want to read this at your leisure, but I'm just going to pick out the important information for now, which is the players that are available for selection and the players he wants to pick for the next game. So as you can see here, we have 3 goalkeepers, 8 defenders, 7 midfielders and 4 strikers available to select. Now for the team, we only want 1 goalkeeper, 4 defenders, 4 midfielders and 2 strikers. This is the equation for combinations. Again, it's a combination because it doesn't matter in which order you put the players. Then for each position, we're going to work out how many combinations there are. I've written the equation down for goalkeeper, 3 choose 1, but obviously there's only 3 because you've got 3 goalkeepers and you only want to choose 1. For defenders, there are 8 choose 4, so we end up with 70 different ways to choose 4 defenders. I've just written down a quick reminder of how to work it out by hand. If you write it out this way, you can cancel out the 4 times 3 times 2 on the top and the bottom. Then the 6 will cancel with the 3 times 2 because 3 times 2 is 6. The 4 you can cancel with the 8, so the 8 will become a 2 because 8 divided by 4 is 2. Then you get 2 times 7 times 5. Then continuing, we have midfielders, 7 choose 4, which ends up as 35 different ways to choose them. Finally, we have strikers, which is 4 choose 2, and the answer to that is 6. So the total number of teams possible is 3 times 70 times 35 times 6, which is 44,100. The second part of the question asks, if he picks 11 players at random, what's the probability that he picked the team he wanted? Picking 11 players randomly from 22 gives us 22 choose 11, which is 705,432. So to work out the probability of picking a team with 1 goalkeeper, 4 defenders, 4 midfielders and 2 strikers, we have to divide the amount of teams possible with those positions, which we've worked out in part A, and divide it by the total number of possible teams, which we've just worked out, 11 randomly from 22. So the answer is approximately 0.0625. In the next question, we have a taxi. We can carry 5 passengers, but we need to take 8 passengers from A to B, from the hotel to the airport. How many ways can you organise the people in the car on the first journey? So we start by writing down the different configurations for the first and the second journey. So we could have 5 on the first journey and 3 on the second, 4 on the first journey and 4 on the second, or 3 on the first journey and 5 on the second. So if we concentrate on just the first journey, there are always 8 people to choose from, and respectively we choose 5, 4 or 3 people. So if we work out all of those equations, we get 56, 70 and 56. So we add them together to get 182 different ways of organising the passengers for the first journey. Thanks very much for watching. I'm going to go through more questions in following videos because I want to try and keep them short. And if you could like and subscribe, I'd really appreciate it. Thanks, guys.